So far we've been given the angle, asked to find the ratio. Now we're going the other direction. Now I'm going to give you a ratio and ask, where did I rotate to get that ratio? Okay, so I'm going to skip this part for a second. I'm going to talk about why this is true after we work the problem. So here's the question. It says, what angle gives the ratio of x based on the specific trig function? And so we're going to get our answers by using the unit circle. So the first one, this is the way we read it. This is called the inverse sine or the arc sine. So those are the two ways you can talk about it. Inverse sine or arc sine. Why arc sine? Because that's asking how much should I rotate? Think about what an arc is. Like my rotation arc. Those mean the same thing. This is the more new school way to talk about it. Inverse sine. That's old school. On the old textbooks, that's what they called it, was arc sine. What did I not say? I didn't say sine to the negative first. I didn't say shift sign. I said neither one of those things. Those are not acceptable. That's not what it's called. Are they talking about the shift sign? No, I'm not. I'm not ever going to be talking about the shift sign. Negative sign. Okay, so again, think about the previous question. If I ask you for sine of pi over 6, then what am I telling you? I'm telling you rotate to pi over 6 and then draw your triangle. This is an inverse sine of the ratio. So what's this telling me? This is telling me I have a triangle that exists. Because I'm looking at inverse sine, I know sine is the opposite over the hypotenuse. So the question is, if the opposite side is 1 and the hypotenuse is 2, where have I rotated to? That's the question. So out of my special right triangles, which one has 1 for opposite, 2 for hypotenuse? It's going to be a 30, 60, 90. Where across from the 30 is 1, across from the 60 is radical 3, hypotenuse is 2. So which angle gives an opposite of 1 a hypotenuse of 2? 30. So from 30 degrees, my opposite is 1, my hypotenuse is 2. So the inverse sine of 1/2 is going to be 30 degrees. Now here's the trick part. Right? That's not the final answer. I just want us to think through this together. It's 30 degrees. So where does a 30-degree angle put me? First quadrant. And that would put me 30 here. Is that the only place I can get 1/2? Is in the first quadrant? Where else could I get it?
The fourth? Second.
In the second quadrant. Because why would the second quadrant work? Because sine is going to be positive there. And then I could draw a triangle that had a 30. And so then how much did I rotate?
90? No, 75.
120.
150 degrees. Because I need another 30 to make it be 180. All the way around. So really, I could have rotated 30 degrees or 150 degrees. So what's the problem here? I'm asking you for a value, and there are 2 possible answers. Well, what's this whole thing been focused on? All of pre-cal. We've been looking at, say it.
Shapes.
Nope.
Graphs.
I thought I heard it. No.
Functions.
That was Joe.
You said Joe.
What's a function?
And you get it. You put something in, you get an output.
Special relation where every input has exactly one output. So if I put in 1/2, now I'm getting 2 outputs. That's not good. I want it to be a function. I want reliability. I want the same thing over and over and over. So what we're going to do is we're going to restrict our domain. And we're only going to allow answers in the first quadrant and the fourth quadrant. So with inverse sine, Why are we restricting it to the first and the fourth? Because what happens to sine in the first quadrant? It is positive. What happens to sine in the fourth quadrant? It is negative. Does this take care of every possible value of sine? All the way, because what is sine? Sine is the y value. Look at your y values here. We go all the way from 1 to negative 1. Do any of those repeat? No. Do I ever get the same y value twice? No. So this takes care of every possible value. So for inverse sine, we've restricted the domain to only be in quadrants 1 and 4. And here's the other part. Our answer is going to be between negative pi over 2 and pi over 2. So our answer is always in radians. So I told you these weren't the answers. This was just our thought process of how to get there. So really, 150 is out because it's in the second quadrant. So a 30-degree rotation in the first quadrant, what would that be in radians? Pi over 6. So that's my answer. Pi over 6. So I did a lot of explaining there. I kind of led you to how to get the answer. I kind of showed you why we have to restrict it. Our normal problems aren't going to take that long. Okay? So we'll work the second one just like I would normally work it. It's asking me for inverse sine. And the ratio is negative. So since inverse sine is only in the first and fourth quadrants, and it has to be negative, I know this triangle is in the fourth quadrant. I know sine is the opposite over the hypotenuse. So I know my opposite side from the angle needs to be radical 3. I know my hypotenuse needs to be 2. What's this angle need to be so that the opposite side is radical 3? 60 degrees. So now in radians, how much did I rotate to get a 60-degree angle? I rotated pi over 3 in the negative direction, so that's going to be negative pi over 3. That's all you got to do.
Okay, how did you know it was in the fourth quadrant again?
Because the ratio was negative. And so where is sine negative? In the third and fourth quadrants. But third quadrant doesn't work. I've restricted my domain to only be the first and the fourth for sine. So I know this has to be in the fourth quadrant. And you may want to make yourself a note there that inverse sine is in quadrants 1 and 4. That way, because when we work on the other trig functions, they're going to be defined in different places. We'll talk about why when we get there. But you can already figure out why. We're ready to do 3. I'm looking for inverse sine. So this is the opposite over the hypotenuse. And I know the ratio is negative. So because it's negative, I know I'm in the fourth quadrant. Because it's only defined for first and fourth. So I'm in the fourth. Sine is the opposite over the hypotenuse. So my opposite side is radical 2. My hypotenuse is 2. So what's this angle have to be? This central angle. 45 degrees. And now how much did I rotate in radians to get a 45-degree angle? And in the negative direction. Because I went clockwise. So it would be negative pi over 4. Questions there? Last one. What's different about 4? It does say arc sine. I didn't even notice that. It says arc sine instead of inverse sine. That's one difference.
Zero there.
Everything else has been a ratio of the opposite over the hypotenuse. This is not a ratio. Which means what? It must have rotated to an axis. It has to be on an axis. If I get 0, 1, or negative 1, I'm on an axis. So what I'm thinking is, I know sine is equal to the y value. So in quadrants 1 and 4, where is the y value 0?
90 and
No.
240.
Wrong. It's right there.
Ah,
That's the only place y is 0.
okay.
Is right there. What's y here? You said 90. What's y here? 1. Is that 0? No. It's here. That's where y is 0.
Are you
So-
sure? At least I'm answering.
How much did I have to rotate to get there?
Zero.
I didn't rotate.
Undefined.
No.
Zero.
0.
It is very defined.
Does it say 1 over 0? So please don't start
A
confusing
number
people.
that represents nothing.
Because it happens way more than you think. So if you're joking, please don't joke. And if you're serious, I need to explain. 0 is not undefined.
A number that represents nothing.
Zero is zero.
Bruce, what's